In this lesson, we're going to be solving absolute value equations. And to do that, we're going to need to isolate the absolute value, which it may already be isolated. And then from there, we are going to set up two separate equations, and we're going to solve each of the equations. So let's see what it looks like. So if we're trying to solve the absolute value of x equals 3. So first thing is, do we have the absolute value isolated? Yes, we do. And so from here, we're going to separate it into two separate equations. First one is going to be the exact original equation without the absolute value bars. The second equation is going to be a negative applied to the entire inside piece of the absolute value. And those are our two setups, and we just solve each equation. This one, there's nothing to do. That one's solved. Here we'll divide by -1, and that'll give us an x equals -3. Okay, so let's verify that it works. So the first one, we plug the absolute value, plug 3 in, so it's the absolute value of 3 equals 3, and then the absolute value of -3 equals 3. The absolute value of -3 is +3, so it checks. All right, second problem. What about if you have the absolute value of x equals -3? So the absolute value is always going to make something at least positive, if not 0. 0 and positive are the only things that you're going to get out of this. The absolute value of 0 is 0. Absolute value of anything is going to be a positive. There is nothing you could plug into this to make it a -3. So this is a no solution. And what makes it the no solution is the fact that you're trying to take the absolute value of a negative. That will stop you every time. So recognition, as you start to set this up, you isolate your absolute value, you're looking for whether you have a positive. If you have a positive, you can separate it into your two equations. If you have a negative, you're done. No solution. All right, so let's see another one. So the absolute value of x minus 3 is going to equal 10. So is the absolute value isolated? Yep, there's nothing else around it. So we'll break it into its two equations. So we have x minus 3 equals 10, and negative applied to the entire absolute value equals 10. And we solve. This one will add 3. So x is going to equal 13. Here you can do one of two things. You can distribute the negative in and then solve the equation, or you can also just divide both sides by the negative, and then that will get you an x minus 3 equals -10, and then you can look to solve that. So add 3 to both sides. X is going to equal -7. All right, so we think those are our solutions. So let's verify that it actually works. So first one, we have the absolute value of 13 minus 3 plugged in. It's supposed to equal 10. 13 minus 3 is 10. So the absolute value of 10 is 10. So that one checks. Second one, we have the absolute value of -7 minus 3 is supposed to equal 10. -7, I like to add the opposite, so -7 plus a -3 makes -10. And the absolute value of -10 is +10. So that one checks as well. And it's not at all a coincidence that we get a -10 on the inside of this, because after we divided both sides by a -1, that's exactly what we are set equal to. So whenever you're solving that and that's what it's set equal to, when you plug it back in, that's what it should add up to. So when we plug in -7, we should get a -10. When we plug 13 in, we should get a 10 inside the absolute value. But the absolute value will make both of them positives. So that one works as well. So let's do another. So the absolute value of 2x plus 5 plus 3 equals 6. So the absolute value of 2x plus 5 plus 3 equals 6. So first thing, do we have the absolute value isolated? No, we do not. That plus 3 needs to shift over to the other side. So we will subtract 3 both sides. So that'll leave us with the absolute value of 2x plus 5 is going to equal 3. So, first question, can we take the absolute value of something and get a positive 3? Yes. So we can break this into our two separate equations. So first one, 2x plus 5 equals 3. And the second one is a negative distributed to 2x plus 5 equals 3. So this one will subtract 5. 2x is going to equal negative 2. Divide by 2. X is going to equal negative 1. This one, again, you could distribute if you'd like. I'll just divide the negative over to the other side. So 2x plus 5 equals negative 3. Subtract 5. 2x is going to equal negative 8. Divide by 2. And we get x is equal to negative 4. So we believe that those are our two solutions. So let's check those. So the first one, the absolute value of 2 times negative 1 plus 5, the absolute value of that plus 3 is supposed to equal 6, and the second one is the absolute value of 2 times negative 4 plus 5 plus 3 is supposed to make 6. So the absolute value of this plus 3 is supposed to equal 6. So let's do the math, make sure everything works. So this is going to be a negative 2 plus 5. Absolute value of that plus 3 equals 6. This becomes 3. So the absolute value of 3 plus 3 equals 6. Oops. So that becomes 3 plus 3 equals 6. The absolute value of 3 is 3. So we get 6 equals 6. So we'll do that one. So that one checks. So negative 1 is good. 2 times negative 4 is negative 8 plus 5. Absolute value of that plus 3 is supposed to equal 6. This adds up to negative 3, which again is what the equation was set equal to. So that's a good sign. And the absolute value of negative 3 is 3. Plus 3 equals 6. 6 equals 6. That one checks as well. So our answers are negative 1 and a negative 4. All right, let's do another one. All right, so this one is going to be 1/2 times the absolute value of x plus 5 minus 6 equals negative 2. All right, so at this point, is this where we decide that we can't do it because we have a negative? No, we have to isolate the absolute value first. So we have to get this piece by itself. All right, and if it helps, you're going to see that the steps that we do are as if we had this. 1/2 times y minus 6 equals negative 2. Instead of having an absolute value, you can kind of consider it looking like this. We want to get this piece, which is our absolute value, by itself. So we're going to bump the 6 over, and then we're going to take care of the 1/2. We're going to bump the 6 over, we're going to take care of the 1/2. So to do that, we add 6. So that's going to be a 4. That'll cancel. So we'll have the absolute value of x plus 5 and a 1/2 in front. So exact same look right here. So we have a 1/2 y equals 4. How do we get rid of a 1/2 multiplied to the variable? We would multiply by the reciprocal. And those multiplying by reciprocal would cancel it out, so you'd have y would equal 8. Well, that y is representing our absolute value, so the math is identical. So we will multiply by the reciprocal on both sides because the reciprocals will cancel each other. So you'll have left the absolute value of x plus 5 equals 8. Now we've isolated the absolute value. We're ready to set up our two equations. Can we take the absolute value of something and get a positive 8? Yes. So great. It means we can set up our two equations. So x plus 5 equals 8, and a negative applied to the x plus 5 equals 8. Subtract 5. We get x equals 3. We'll divide by negative 1. X plus 5 equals negative 8. And subtract 5. X equals negative 13. So we'll kind of just see if we can mentally plug these in and check. So if we plug 3 into this, 3 plus 5 would equal 8. The absolute value of 8 is 8. Half of that is 4. And 4 minus 6 would equal negative 2. If we plug negative 13 in, negative 13 plus 5 adds up to negative 8, which is what it was set equal to. And half, the absolute value of negative 8 is positive 8. Half of positive 8 is 4. 4 minus 6 would equal negative 2. So 3 and negative 13 work. One more. So the absolute value of 2x minus 5 plus 7 equals 4. Alright, so we need to isolate the absolute value. This time is a little bit less work. We just subtract the 7 over, and we have a negative 3. So the absolute value of 2x minus 5. Now always ask that question, can you take the absolute value of something and get a negative? So that again is our problem. You cannot take the absolute value and get a negative of something. So nothing will work. No solution. Alright, and that was solving absolute value equations.